Hello, we are Group 8 and today we are going to present our topic, dams and waterways. We have reviewed 7 projects such as Hoover Dam in Nevada, Elephant Butte Dam in New Mexico, and we also reviewed the dam failures such as Teton Dam failure. There are mainly 4 types of dams according to the building method and material type that is used. They are earth or rock fill dams, gravity dams, buttress dams, or arc dams.
Constructed from concrete, stone, and masonry, the gravity dam's name stems from the fact that gravity is essentially what's holding it to the ground. The mass of the material alone is enough to resist the horizontal force of the water it's retaining. An advantage to this type of dam is its durability. However, they require a long construction period and high construction cost, but are still relevant because of their low maintenance cost and no sudden failures. The construction process is relatively simple, starting with water diversion, excavation and pouring of foundations, and concreting the dam itself, creating a dam that could last upwards of 100 years.
The phases of construction for the earth dams start with mobilization. After this, diversion of water. Then the excavation, in which it needs to be determined if you're going to do slope or short excavation. After this, the foundation. And after this, the layering and compaction of soil and engineer fill. And at the end, the facility work, the construction of mechanical and power features of the earth dam.
Building a concrete batch plant is a typical way to provide the concrete. Roller compacted concrete is a hard mixed concrete cement containing less cement. This enables to compact the poured concrete by rollers and limits the heat. This stiffness and the low temperature makes the entire area of concrete to be poured at once, immediately after the previous layer finishes.
Buttress dams are a type of gravity dams, and what's unique about them is the presence of buttresses on the downstream side to provide support. The construction process and lessons learned are similar to those of gravity dams, with few variations. For example, we can construct buttress dams on weaker foundations with thinner sections and thereby using less concrete. However, that leads to the dams being more susceptible to damage, and the saving in concrete costs is often offset by the cost of formwork and reinforcement needed to build the buttress system.
Arch dam is an economical option for narrow canyon in countryside. It's typically designed as a curve upstream, and thanks to this design, the wall can be built thinner than usual. Besides, the construction is similar to gravity dams. There are lots of examples of arch dams such as Hoover Dam in Nevada, Arizona, and Morro Point Dam in Colorado.
The earth dams are the ones that are constructed from the material that is found on site. There are 2 kinds, earth-filled and rock-filled. The difference between them is the material found in the excavation and the ability to borrow it. The advantages of the earth dams are that they have a relatively lower construction cost and the earth is easier to handle. But on the other hand, they have higher maintenance costs and they have greater susceptibility to failure.
The Tom Sauk and Teton Dam are both examples of earth dam failures. The Tom Sauk failed from overtopping, the most common failure for earth dams. In this case, it was caused by malfunctioning sensors that failed to indicate that the reservoir was full. The Teton Dam failed due to internal erosion where water seeped into the key trench at the right abutment.
Another structure dealing with water is waterways. Waterways are constructed starting with mobilization, then constructing a temporary structure that holds water behind construction, followed up by excavation, constructing of canal walls, constructing of gates and locks, then ending up with filling in the canal with water. Few decisions to be made from construction perspective include the decision whether to have sloped excavation or short excavation, depending on cost and space limitation. Another one is the need for dewatering system, depending on the depth of water table relative to our excavation. And finally, is the canal ready to be filled with water, depending on soil erosion risk and load impact.
Waterways, locks, and gates. They are used for the water control and transportation. The construction process for such locks and gates is as following. Water in the gate should be pumped out, and after letting the area dry, piles will be used in the geotechnical to support the soil. After that, wooden form will be built in the site, and reinforced steel and concrete will be poured in the site. After that, concrete valves and all hydraulic and mechanism equipment will be installed in the site. Gates are designed and fabricated out the site and delivered to the site. Finally, installing all accessories like escaping ladders.